If we want to control this ourselves, then the operating system gives us a syscall to do that. And the mmap system call has a lot of arguments because it gives you a lot of control over those entries in the virtual memory table. So mmap takes an address. Usually we're going to pass null for the address. You can pass an address in, which is a kind of hint, depending on what flags you provide, to say, please give me an address. Please map a new page that's close to this address that I give you. But null means that you're telling the kernel, I want some more memory. You can map it wherever you want to in virtual space and just tell me what the place you map it to. And that's what comes back. The length argument in map tells it how many bytes you want to map. It's in bytes, but really it's in pages. So the length will be effectively rounded up to a page size to map pages, that many pages of virtual memory. The prot argument, the protection argument, this is a bitwise combination of prot read, prot write, and prot exec. So you get to pick what permissions are allowed for a given page. Flags we'll talk about more later. For now, you just use map private, and you use map anon if it's corresponding to memory that's not connected to a file. On the other hand, because the virtual memory system is sort of implicitly has this connection to files when you think of it as a caching operator, then you can also pick a given file and say, make the virtual memory at whatever address is picked, make it correspond to the content of the file. So in a sense, that virtual page starts out paged out onto disk, and the file will be loaded into memory on demand. And if you do that, if you provide a file through a file descriptor, you can also provide an offset. So you say how far into the file should actually be mapped if you don't want the whole file but just want some portion of it. If it doesn't correspond to a file, though, you use -1 for the file descriptor, 0 for the offset, and also include the flag map anon to say it has nothing to do with files, it's just some memory. We saw this before when we were reading in ELF files. Now we understand all the pieces that I used here, because I opened the file using the open syscall to get a file descriptor, and I got the length of that file using some other syscalls. But then the key part was using map to say, pick an address in virtual memory to mean the content of that file. And we only needed read access to it, and we used map private because that's what we're doing for now. And we did not use map anon because it did correspond to a file. On the other hand, if we wanted to allocate a brand new page of memory of virtual address, then we would use mmap with null. Here I'm just allocating one page, and you can get the page size using the get page size system call. This page I'm allocating is readable and writable, and it's not connected to a file. So that's why there's -1 and map anon there. Let's put that in a real program. So here's a program that's going to allocate 1 shifted by 14, so that will correspond to 16K of memory, or about 4 pages, exactly 4 pages. We allocate that memory, we get some address that the operating system picks, and we can write into that address since I've made it writable. I've also made it executable, so we'll be able to jump to that address. So if you needed to actually generate code at runtime, this is how you would do it. You would create your own memory that you can write into and that you can execute. So compile that, run it, and you see it was okay. If I take out executable address, then let's print out whether we wrote successfully or not. So I still have readable and writable, but not executable. So we should be able to write, but not execute. And there we go. That's what we saw. On the other hand, if I take out write as well as execute, then we won't even get past this line. We'll just get trying and then a segfault. And that's what we see.